Gravitation Part 4 Mass and Weight. In the previous video, we learned about free fall. In this video, we will learn about mass and weight. Mass and weight are often confused as the same thing, but they are absolutely not. Remember, we learned that the mass of an object is the measure of its inertia, and we also learned that greater mass offers greater inertia. Now, let's understand more about mass and how it is related to weight but is not the same as weight. Mass of an object remains the same everywhere. It doesn't matter whether the object is on the Earth, the Moon, or even in outer space. Therefore, we can say that the mass of an object remains constant and does not vary from place to place. We know from the previous video that the Earth attracts every object with a certain force. The weight of an object is this force with which it is attracted towards the Earth. This force is defined on the basis of the mass of the object and the acceleration acting due to gravity. As we have learned, force is equal to mass multiplied by acceleration. Here, the acceleration is the acceleration due to gravity. Therefore, we can say F is equal to m multiplied by g. Denoting the weight by W, we can write the previous equation as W is equal to m multiplied by g. Mass and weight are two different properties of an object, and that is why they have different units of measurement as well. As the weight of an object is the force with which it is attracted towards the Earth, its SI unit is the same as that of force, which is Newton, whereas the SI unit of mass is kilogram. Weight is a force which acts vertically downwards, so it has both magnitude and direction. Another important distinction is that the mass of an object remains the same everywhere, whereas the weight of an object varies with the position of an object, because acceleration due to gravity varies with position. Remember, we learned in the previous chapter that the value of acceleration due to gravity is more at poles than at the equator. Considering that, where do you think you will weigh more? At the North Pole or at the equator? Your weight will be more at the North Pole than at the equator. But keep in mind that the difference will be relatively small. Now, let's take another example. Let's see how the weight of an object varies on the Moon. How do you think the weight of an object will vary on the Moon? Will the object be heavier or lighter on the Moon compared to when it was on the Earth? Weight of an object on the Earth is the force with which the Earth attracts the object. Similarly, the weight of an object on the Moon is the force with which the Moon attracts the object. Now, let us find out what is the force on the Moon. Let the mass of an object be m and let its weight on the Moon be Wm. Let the mass of the Moon be mm and its radius be rm. We know that according to the universal law of gravitation, F is equal to g multiplied by m multiplied by m upon r square. Now, by applying the universal law of gravitation, the weight of an object on the Moon will be Wm is equal to G multiplied by mm multiplied by m upon Rm the whole square. Let the weight of the same object on Earth be We. Let the mass of the Earth be m and its radius be r. Now, by combining two of the previous equations, G is equal to G multiplied by m upon r square and W is equal to m multiplied by G, we get We is equal to Gm multiplied by m upon r square. Have a look at this table, which gives us some information about the Earth and the Moon. Now, by substituting the values from the table in the previous equations, we get Wm is equal to 2.431 multiplied by 10 raised to 10 G multiplied by m. We is equal to 1.474 multiplied by 10 raised to 11 G multiplied by m. Now, dividing the previous equations, we get Wm upon We is equal to 2.431 multiplied by 10 raised to 10 upon 1.474 multiplied by 10 raised to 11, or Wm upon We is equal to 0.165, which is almost equal to 1 upon 6. Weight of an object on Moon upon weight of an object on Earth is equal to 1 upon 6. Weight of an object on Moon is equal to 1 upon 6 multiplied by its weight on the Earth. What will be your weight on the Moon? Now, let us solve a problem together. The weight of an object on the Moon is 50 Newton. How much will the object weigh on the Earth? Pause this video and make your calculations. Weight of an object on Moon upon weight of an object on Earth is equal to 1 upon 6. Weight of an object on Earth is equal to 6 multiplied by its weight on Moon, which is equal to 6 multiplied by 50 Newton, which is equal to 300 Newton. In this video, we learned about mass and weight. In the next video, we will learn about thrust and pressure.